Once upon a time, there was a prince trapped in a tower by an evil physicist and his stereotypical dim-witted guard. One day, after weeks of imprisonment, the prince saw a damsel wandering past the castle in which the physicist held him. Seeing this opportunity of freedom, he shouted to the damsel, projecting his longitudinal sound waves.
Help! I'm in distress. Ah!
Sound waves are the transfer of energy. Air molecules hit each other and transfer the sound to the person's ear that is hearing the sound.
There's a message in the ball!
Yay!
The law of conservation of energy allows for 100% transfer of elastic potential energy to kinetic energy. Knowing the spring constant of the slingshot and how far back the slingshot is pulled, we can determine the elastic potential energy side of the equation to figure out the velocity of the tennis ball.
Okay, I'll get right on it.
Where is it?
I'm here to rescue you!
Yay!
To calculate projectile motion, the first step is to use the equation v equals delta x over delta t to calculate the horizontal velocity of the ball. The second step is to use the constant acceleration equation delta x equals 1/2 at squared plus vit to calculate how much time the ball will be in the air. We finally plug these values into the equation v equals delta x over delta t to calculate how far the ball will travel from the base of the balcony. In this way, we will project the ball far enough to distract the guard so that the damsel can rescue the prince.
I got this penny,
And I've got this basketball.
and we'll drop them on you.
And they're gonna hit you at the same time.
Oh no!
Newton's second law, force equals mass times acceleration, can be manipulated to form force over mass equals acceleration. In this way, we can represent a large mass falling at the same acceleration as a small mass with the equation big F over big mass equals acceleration equals little force over little mass. This proves that the penny and the basketball will land at the same time if dropped at the same time.
As the damsel spins the rope in a circular path, the end of the rope is pulled towards the center by the centripetal force. Centripetal acceleration and the net force are also toward the center. But as she lets go of the rope, it will fly in its intended path straight forward at the point of release due to the centrifugal effect in Newton's first law.
The tension of the rope can be calculated by the equation force equals gravity times mass. The value of the gravity is always 9.8 meters per second squared, times the mass of the prince hanging on the rope. The units meters times kilograms over a second squared equal newtons, which is the unit of force. We can use a force diagram to determine the acceleration of a ball rolling down a hill, chasing the dim-witted guard.
Using vectors and the equation work equals change in position times force, we can determine the work the damsel is doing to pull the prince in the green wagon away to live happily ever after.